Welcome to this video on application of matrices in electrical and electronic engineering. Here we will be discussing loop analysis techniques. If you haven't checked out our previous video on matrices, you may find it useful to watch first. To understand the importance of loop analysis, consider this circuit. It has two sources, and there is a parallel branch. This makes it difficult to consider the current flowing through each component. That is because the currents due to each loop I1 and I2 will interact, and we see a combined effect. So we ask ourselves the question, how do we solve? The answer is loop analysis. The aim is to consider Kirchoff's voltage law around each loop, giving two unknowns, I1 and I2. Hence, we use KVL to come up with a pair of simultaneous equations to be solved using matrices. Starting with loop 1, KVL has been considered so that the sum of the voltages is 0, remembering that direction is important. We will assume that I1 is greater than I2 so that the resultant current flows through R2 in the direction of I1. As a result, we consider R2 times I1 minus I2, which has been expanded as seen here so that I2 times R2 has a plus sign. We do a very similar analysis in loop 2. It is important to remember that we have to be consistent in our assumption that I1 is greater than I2. Be careful at this step, as it is a source of common error for many students. Once the equations have been rearranged into a simpler form, we can put them into this matrix multiplication, which is equivalent to the simultaneous equations. This allows us to substitute any value of R1, R2, V1 or V2 into the equations and get a result. Now all that is needed is to solve the matrix equations. Solving two simultaneous equations is very simple. So you might be asking why matrices are necessary. Consider this circuit with 4 loops and multiple sources. There are 4 loops, allowing us to find the 4 equations needed to set up the system of simultaneous equations. Although this looks like a complicated circuit, it is a simple case of analyzing each loop at a time and considering any components that have some overlapping current. Now, if you try to solve a system of 4 simultaneous equations, you find it is a long process. Again, what if we have 1 million loops? The answer is that the easiest method to use and the most powerful method lies with matrices. To conclude with some final remarks, this video has covered the basics of loop analysis, showing how matrices can be used to solve complex problems with a high number of variables with ease, demonstrating the power of matrices in engineering. Like and subscribe for more, and don't forget to check out our other videos.